welcome. Thanks for tuning in. It is kind of amazing to be here back at Maker Faire 2020. I hope people have been enjoying tuning in all around the world for the 24 hours of Maker Faire. It's a very different Maker Faire, as you can tell. It's just me and my workshop here, and I miss you guys. I miss everyone. I miss Paella. All I got is my friend Lars here to keep me company, but I'm excited to be here nevertheless. And the theme, or one of the themes for the Maker Faire this year, has been people's responses to the COVID-19 situation and the coronavirus. And so I wanted to show a couple of DIY projects that I built that are related to your health, namely hand washing timers. So the basic idea behind this is that the Center for Disease Control and Prevention guidelines for hand washing say that you should wash your hands for 20 seconds with soap, scrubbing really well. And so a lot of people, I think, found early on in paying attention to this that they were getting bored of singing Happy Birthday, which is the general guideline for getting a good 20 seconds in. And I guess most of us sing that at the same tempo, but you might go fast, you might go slow. And so it was actually my daughter's suggestion. She said, "Hey, Dad, can you make a hand washing timer?" And I can't remember if I had prompted her, like, "Hey, what project should I do this week?" Sometimes she gives me ideas for projects that I build for my Adafruit show, for the John Parks Workshop show on the Adafruit stream. I do a Make Code Minute section, which is a lie because it's usually more like 2.5, 3 minutes. I think maybe it was for that she said, "Hey, it would be really cool if you'd make a hand wash timer." But she actually wanted one. She wanted to have a timer for her bathroom sink so that she could stop singing or looking at a watch or trying to deal with a phone and just have some sort of a timer. And so I came up with actually a couple of different versions of this. And the reason I wanted to do this talk was I think it's interesting to look at somewhat the evolution of and accessibility of coding for microcontrollers, as well as the addition of lots of sensors and inputs and outputs onto microcontrollers that's happened over the course of definitely the last 15 years or so that we've all been going to Maker Fairs. And this I haven't built this project using older technologies or previous technologies, but I'll try to describe a little bit some of the differences between how I would have done this years ago and the ways that I can do it now. So I actually did two versions of this project. And so I'll show you the tutorial that I created that is in the Adafruit Learn system that shows a couple of variations on the project at sort of two different not even necessarily skill levels, but to some degree. There's a very accessible version in the Make Code, which is a graphical interface for creating your code, the logic of your software, no typing required, as well as a CircuitPython version, which is a very modern and convenient and accessible coding style of programming language that runs on a bunch of different hardware. So I'll show those. I'll show the tutorials that I created for those. I'll show you the hardware that I have that these are running on. I'll even maybe indulge you, me, someone will be indulged in a hand washing demo, except it'll be a virtual mime one. I think I've got some mime training, so I'll be able to handle that. Because I don't have a sink in here. I don't have a sink in my workshop here. I do have some videos of it in action, and one of the interesting things about this was that we're always learning, and the fact is, when I first approached this project, I had no idea how to properly wash my hands. I was putting a little soap on, and then I was spending all my time under the flowing water. And it turns out that's not what kills viruses and bacteria. It's the soap itself. So I learned a lot with that. I had a video up, and I yanked it down, actually. I think I was so shamed by people telling me, "Please do not spread bad information about how to do this." So I also want to acknowledge the the chat going on, the conversation with people. I don't think I have a good setup here for showing chat that's going by, but I'm keeping my eye on the chat over in YouTube where this is streaming. And I have, you may be watching on the Adafruit YouTube, or you may be watching on my personal YouTube channel, because that link was up first, so I decided to stream to both of them, and I hope that's working out for everyone. So I'm seeing chat in both, and I just want to say hi to Sandy Roberts for popping in, Danielle Martin, also missing the paella. Sandy says there should have been a paella making workshop. That would be fantastic. Can anyone get in touch with Gerard? That would be a really appropriate and wonderful class to learn about some of his paella secrets. If you don't know why I'm talking about paella, at some of the Maker Fairs, definitely the New York Maker Faire and the Bay Area Maker Faire, the tradition had been for many years on Friday night before the real weekend got kicked off to have a sort of family-style dinner of paella made by a paella maker up in the Bay Area named Gerard. And it was delicious, and we miss it. Let's see, what else? Oh, hey, Gregory Hayes. Yeah, missing Maker Faire. Absolutely. What a family, and it's so cool that, that Make Magazine is keeping Maker Faire alive in this time when we can't be together physically. So it's really wonderful. Let's see. What else we can say? I'm checking the other one. There's some questions about Lars and Slappy. That's Lars, the sloth. Some of you may know Slappy. He's not, I don't think I have his batteries charged up, so his eyes aren't going to do anything, but there's Slappy. But I don't want to scare anyone. That's not why we're in this. And Slappy likes to scare people, so he can stay out of it. Lars just wants ice cream. Okay, so let's get into this. So first of all, let me talk about the hardware a little bit that we're using. So I'm going to bring up, let's see, how about not that one, but how about I'll become that, and this will become this. And, oh, I can even scale this up a bit, so bear with me if you will. This is how you know it's a live demo, because real things are happening. And let's take a look at, let's talk about this first one. So this first project is going to be on this piece of hardware. I have two of them here. This is the Circuit Playground Express. This one you'll see, this one's shiny, and that's because I have it in a case. Ooh, I'm spoiling the demo by having it plugged in. I had a battery plug in. So this is the Circuit Playground Express, and it's a microcontroller board. You can see it right there in my browser. That's the sort of main tutorial about getting started using it. The microcontroller, if you're not familiar with microcontrollers in general, a lot of us got used to or started out in microcontrollers with the Arduino Uno or some of the earlier Arduinos. So you may hear that phrase around. An Arduino or a Circuit Playground or a Feather. These are all a Trinket, a Gemma. These are all microcontroller boards, meaning they have a little bit of a computer chip on there for a brain. You can program them. They tend to be very simple, much simpler than your computer or your tablet or your phone. And generally speaking, they have input and output pins on them to which you can connect things like lights and motors and knobs and buttons and switches and slide switches and speakers. So they're used for something that used to be called physical computing. I don't think that term is in vogue anymore, but it has to do with building things that do things when they react to an input, or can drive external things like motors and speakers and lights. In the earlier days, these tended to want you to plug in things to them to do much of anything. They could blink one LED, or they could do some thinking, but there was no sign to us what was going on. With these more modern boards, such as the Circuit Playground Express, one of the really neat features of them is the amount of stuff packed onto it. In fact, do we have a graphic? We probably have a graphic on here that shows some of the things that are on here. Here's a little guided tour page. So this shows there are colored LEDs running around it in a ring. There are pads on the sides that can be used as touch sensors. There's an accelerometer built on, so it can tell things like shaking and tilting and angle and tap. There's a microphone built into it so it can react to sounds. We're going to use that in this project. There's a speaker so you can play some little sounds. And there are a couple of buttons and a slide switch. And we'll talk about some differences with the Clue in a minute, but what this leads up to is the ability in this to use a sort of self-contained, build a self-contained project that really just needs power. So either a battery or in my daughter's bathroom, for example, we have it just plugged in with a thin little USB cable over into a GSI socket. So it's always got power over the USB cable. And what we can do with this is program it to react to, in this case, a loud sound or button push. So for the hand wash, what I wanted to do was allow it to stay untouched. So you don't want to put viruses on it and then wash the viruses off and then go touch it again and get your viruses back on your hand or whatever germs or bacteria or dirt. So I want it to be hands-free. The button press I have on there just for testing purposes, but no one uses that. Don't use that. In real use, what I wanted to do was allow you to either snap your finger or clap, or you can yell at it if you're feeling like yelling at it, pound the wall with your elbow, whatever you want. Anything that registers as a loud sound will start the timer. And in this one, I also decided I wanted the timing to be based on the circle of LEDs spinning around. And since we have 10 LEDs and I wanted to do 20 seconds, I figured we would just go around twice and change the color so we can see it counting down one color ring and then a second color ring, and now we know we're done. There's some differences that we'll see with the Clue version where we have a graphical screen that we can use instead of LEDs, as well as I decided to use the speaker on that project. So how about let's take a look at the guide that I created for this. So here you'll see, and we'll take a look at these demos in a minute, we can see on the Circuit Playground Express for the guide here, you'll see I've got a little demo of what's going on the board. And then I have this image here. And the neat thing about the way I coded this is that I used the Microsoft Make Code platform. And if you're not aware of this, Microsoft has done a really incredible job creating a very easy to get started with programming language or an environment that's called Make Code. And there are versions of this that run on things like Lego Mindstorms robots. You can use it with the microbit. You can use it with a whole bunch of microcontroller boards, from some of the Arduinos to the Feather boards and trinkets, as well as many, many others. There are, I would guess, dozens and dozens of boards that you can use Make Code with. And I think one of the real premier things of it is this graphical interface. There are also modes where you can use JavaScript, which is typed code, or Python, which is also typed code. But I really love this graphical environment for a number of reasons. One, I'm a visual thinker, and I like looking at the logic of something in a somewhat flowcharty way, and I like to move parts and pieces around so I know, oh, that's a section of code that does this, and I'm going to put it over there, and it's real big, and I kind of have a bunch of cues as to what it is, versus one long linear text code, which is not as visually appealing to me. And it's also helpful because it gives you a whole bunch of starting blocks to work with that just jog your memory about how you might go about something, or if you're not sure, you can kind of look through what are my options versus staring at a blank page, which can be daunting. So if we look at this is my actual Make Code session, and so this is running inside the browser. I'm going to make this even bigger so we can really fill out the space there. I'm going to put on my reading glasses too. This is how you can tell that Maker Fairs have been going on for a long time, because I didn't used to have gray hair in my beard and reading glasses years ago. So what you see here in the Make Code interface is a simulator. That's what this Circuit Playground Express sitting there is. It's not just an image, but it's actually a functional simulation of how the hardware works. And then over here on the right is what I call the canvas, but it's sort of the main programming area. So I just moved the simulator out of the way here for a second so I can take a look at my program. And you can see we get to move around. We can even zoom in and out here. And the categories here on the left are where we can bring blocks into this center. So if I'm staring at let's pretend that's entirely blank, and I say, you know what, I think I'm going to do something with lighting up lights to begin with. I'll head over into this light category and look, and oh yeah, right away there's a really nice, hey, show this ring. I can bring this into here. I can customize maybe what the starting colors look like on my block. And very quickly, especially if you just take a couple of minutes to do some of the first tutorials, you'll find that there are programming structures that almost always exist in these programs, such as a setup section called onStart, and very often a forever section, which is the main loop of what happens in the program. And you can just change your mind about things and drag them off to the side to blow them away, and they're gone. So what I'm doing with the program here, I'll go over what's actually happening, and you'll learn a little bit about some of these blocks and how I have them set up. So on start, this is often some housekeeping stuff to get going with. First thing is, I didn't want it to be crazy bright. So I've set this brightness value to 10. I think this is out of a total of 255, so it can get insanely bright. So I set the brightness a moderate level. And then the next thing I'm doing is actually calling a function. And remember I said I like to break my code off into different pieces. So a function is a little block of code that's discrete and can be used whenever you want. So right away I'm calling the blink function here. And what is the blink function? It's this chunk of code right here that takes a couple of arguments. So you may have seen I said call blink, and then I gave it a 1 and a 2. Well, what do those mean? When I look at this function, it says the blink function, whatever the first number is, that's a color value, or something to do with color, and times, that's how many times I'm going to blink. So essentially, I want to blink 2 times, and I want it to blink green. That's just my startup thing, the first thing that happens when it starts. And so the way I'm doing that is I have a loop that repeats however many times I told it, so this is the 2 times. And what it does 2 times is it sets all the pixels to black, which is off. It waits 100 milliseconds, so just a little brief moment. And then here we have a conditional check. It checks to see if the color value that was entered is a 0, do this, be red. If the color value that we entered was a 1, do this, be green. So remember, I fed it a 1, and that means that the green is the one that's going to get used. And then we pause again. So if we look at the simulator, when this starts up, there it blinked. You might have missed it, so I'm going to run it again. So I'm going to restart this, and blink, blink, it blinks twice. So that's the startup, and then I also have a little variable here called duration, and that's how long I'm setting the hand wash timer to. I always have it set to 20. I just added this for demonstration purposes, so if we want to see it happen a little faster here during this talk, we can. So at this point, when this runs, it's going to stop right there. When we start up the program, it's going to blink twice, and then it's just waiting. And what it's waiting for is one of these input blocks to do something. So I have, like I said, either the on loud sound, or I have this button click, which is more for my testing purposes. So on loud sound, that's a very specialized block. It comes from inputs here, and you can see it right there. Just there's a ability to set a threshold if you want to, but by default it does a pretty good job of not always running based on little background noises, but just waiting for something pretty loud. And a quick question that I'm seeing in the chat is, what is this software? And the software is MakeCode. And it's at, you can find this version at makecode.adafruit.com, or the general family of MakeCode, which runs on a bunch of different hardware and platforms, including Minecraft, is just at makecode.com. And okay, so when a loud sound happens, what happens? 2 other functions get called. So again, I didn't want one big long thing of code sitting here to look at, so I broke it apart into some functions. The first one is prep the countdown, and I give it the duration. So in this case, it's going to be prep countdown for 20 seconds is what I'm entering there. And what happens now is for 0 to that number 20, it's going to repeat that many number of times. And in this type of for loop, it will also automatically increase the number with each run through. So it'll do something with a 0, and then a 1, and then a 2, and then a 3, and so on. And so what I'm doing there to make this run is I'm saying if my index value, which is that number, that counter, is less than 10, then we'll do something essentially running through the first 10 pixels, and then the remainder of that would be the second two. And this is how I worked around the fact that we don't have 20 pixels to work with, and I want it to go 20 seconds, so around twice. We set the pixel color to blue, sort of cyan blue, and we pause. And that's essentially changing one pixel at a time, going upward, because this is the preparatory one, so this is counting upward. And then the second time around, it's going to do it green. So let's watch that. If I open up the simulator and I either press A, which is going to call this, or I can do loud sound, which in the simulator is just this little icon here, which I can crank up high. You can see it's counting up. And this only takes 100 milliseconds between, so that's not the seconds count down, that's the count up. So I'll stop that because that's actually going to move forward, and we haven't talked about what happens after the prep. So if we look at our on loud sound input here, we're going to call the prep, and then we're going to call the countdown. And the countdown is right here. This one kind of works like the count up, or the prep, in reverse. So again, we're going in a indexing loop from 0 to 20, let's say. We're setting a variable, so this is kind of a holder for number that's just going to hold on to whatever the value of this little equation equals. So the counter initially is going to be the number of seconds minus the index plus 1. So if that's 20 minus 0 plus 1, the counter is set to 1. I'm even logging that in the console just so I can see it, which is neat. I'll show you that in a second. It's a way to graph values or print out things so that you can debug your programs or make sense of what's happening in them if you run into any issues. So we set that counter value, and then we look at, okay, is that counter value greater than 9? Okay, it is for the first 9 times through, because we're starting at 20. So we're going to pause for 1 second. This is our 1 second countdown. And then we're going to change the pixel color to this magenta color. And we have to use a little tricky piece of math, again, to loop through 10 pixels instead of 20. That's what this is. This is kind of a modulo math. And then when we've gone through the first 9 of them, instead of them changing to magenta, they change to blue. So again, that's how I'm running 10 pixels as if they're 20. And when all of that is done, so it runs through those 20 seconds, then we're going to set the pixels to red. We're going to wait a second. We're going to blink 3 times, and then we're going to turn it off. So that's the full loop there. So let's have a look at the simulator here. It counted up. It counted up. It's counting down, 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 all the way. If I open up the simulator here, you can see those are those numbers that I was using just to make sure I had things right, because I had to like add +1 to it to start essentially on the 21st pixel going down kind of off the top of the thing. So simulator is good, but let's look at it really in action. So in fact, I really like this demo video. Let me show you this. So here is, and I'm not sure if you'll hear sound or not. You may. It may echo. Let's find out. Let's take a look at the real deal here. So I've got, let me show you my, I can go to a down shooter camera here. So here it is, and like I said, we have a case on this, which is really nice, and it keeps splashes off of it. I'm going to power it from a battery here. Okay, so there's that startup. Remember, it blinks a couple times. And then I can just snap my fingers, and that starts it. Runs through the 2 startup color rings there. And I think this is fun too because you have to be creative with the interface a little bit because like I say, we want to do 20-second countdown. We don't have 20 LEDs, so I decided let's just run through 2 sets of colors. The reason I count them up is to kind of put that idea in the user's head that there are going to be 2 sets of colors rather than just immediately start counting down. It also gives you a moment after you snap your fingers or make your loud sound to get your soap on your hands if you haven't already and get going. So that is the Circuit Playground Express version. And now if you look back at the tutorial here, this is the Learn Guide, you'll see that I have 2 versions. One is the Circuit Playground Express timer that we just looked at, and then I also have this Clue hand wash timer. So the Clue is, let me go full screen, not screen, screen again. Oh, I've started the timer. Let's reset it. Oh, that's so many of me. So many. There we go. So this is the Clue board. Mine's restarting right now. And this is in the microbit form factor, but it's a much more modern and powerful chip on here with a lot of extra features. So it has enough memory and enough speed to be able to support a TFT display. That's this little screen you see on here. As well as a bunch of other features, including Bluetooth and on and on and on. The way that I'm using this one to trigger it is if you look closely, in fact, let me go to let's go to the overhead and see if I can avoid triggering it while I put it under the overhead. This has a proximity sensor built into it. And so it's a little washed out just from my overhead camera, but that little black box that you see at the top there, okay, it just registered that I put my finger in front of it. That can tell the proximity of an object from about 2-3 inches away and closer. With pretty fine precision. So all I have this doing is while it sits in idle, it just waits for something to get close. So this is really just a wave your hand to start it. And then you can see it changes the graphic and it counts down and then it just goes back to its starting point. Yeah, I've triggered it again, so let me unplug that battery from there. So let's take a look at the code for this because this is a little different story. I'm coding this one with CircuitPython. And so here's what CircuitPython looks like. This is kind of a more traditional scripting language code. It's very, very similar to Python, if you've heard of that. So it's not using those graphical blocks. It is instead using typed code. And this is what, about 100 lines, maybe 88 lines of text code I have in here for this program. And I won't go into excruciating detail in this, I promise, but I'll give you the broad strokes of what this does and how this works. First of all, one of the very cool features of CircuitPython is I don't need a dedicated programming environment or integrated development environment, an IDE, you'll sometimes hear that phrase. I don't need that to code this. All I need is a text editor and to plug this in because it shows up as a USB drive. So plug it into your computer and you can find this one very important piece of code on here. It's called code.py for Python, pi. Code.py, whatever you make that be, so if I edit it and hit save, it automatically runs that code. So there's not a preparatory step of compiling the code and having the memory flashed. It just runs off of a little piece of thumb drive style storage, USB drive, stick drive style storage that's built onto here. So this code right here, if I plug the board in and open the code, I can edit it essentially live, and every time I hit save, it runs. On the board, there are some little helper bits of code called libraries, and so the first thing I'm doing is importing libraries, and these allow me to do things like very easily put displays on screen using things like bitmap fonts, and allows me to play sounds using this thing called Pulse I/O, allows me to look for the proximity of a hand getting close using this proximity sensor inside of the Adafruit Clue library. Next thing I'm doing is a bunch of display stuff. So I'm setting my display's brightness to be a little less than full. I'm setting it to 80% with this 0.08. I'm setting up little groups of objects that will show up on screen, including a couple of bitmap files. So I just made some artwork that I could display on here of that little robot hand that you saw. It's our AdaBot and a little faucet and some bubbles. And I'm also setting up the ability to display text because I want the word hand wash timer on there. I want the word wave your hand to start. So that's all setting up this text. The colors of them, the label sizes that I'm using, all of that stuff is in here. And then I've set up a little function. Remember I talked about functions before in MakeCode? Here's the same sort of thing happening. And that's one of the nice things about coding in both graphical environments and text environments is that code tends to follow the same sorts of structures and rules. So it's convenient for me to make a function of code. And I can do that in blocks and I can do that in typed code, which I'm doing here. So I've made a little function called countdown, and it just takes an argument seconds. So again, I'll feed that a 20, and then this is the loop, just like we saw before, for I, which is like index, in a range of seconds, which is 20. Do this thing 20 times. What it's doing, it's beeping my buzzer at a certain pitch. It's changing the text of how many seconds we have left. That's a countdown timer there. It's turning the buzzer off, so that just beeps very quickly. And then it waits 1 second. So I'm just using this function called time sleep. When that finishes, so that's the countdown right there, it then does a bunch of housekeeping, like changing it to say done and wave to start when it's time to start again. And then the buzzer setup here is a little bit of housekeeping for how I'm using the buzzer. And then finally, this is the real guts of the program. Let me zoom in here. This is actually what happens over and over again. I hid this. This is a print statement, kind of like that console graph I did before. For my debugging purposes, I wanted to see this printing out, but I don't need it in the end. So what happens for the main function? This is it. Just like our orange input for onLoud sound that we had with MakeCode, here I have this if the clue.proximity is greater than 1. So that's the measurement of the clue proximity sensor, and if it's at 0 and then I get within its range, at some point it gets to 1, that means you've waved your hand pretty close to it. I then move my labels around, so I bring that label that is counting things down onto the screen for the timer. I type in the word scrub away, and then we set the wash off sprite on, move that off of the screen, and then we finally are doing the countdown 20. So that's actually calling that function as it existed before. So here's a demo of the just that in action, no hand washing. There we go, and here it is in practice in my daughter's bathroom. See, the screen doesn't video too well sometimes. All right, so the last thing I wanted to do was, I had forgotten to mention, since we were talking about the differences between the graphical code and the typed code, I wanted to go back for a second to looking inside of Chrome at the, this is the MakeCode code block version. I'll move the simulator out of the way here for a second. And here is the JavaScript equivalent. So you'll probably see some familiar things in there. It's not exactly the same as Python, but you'll see a lot of the same ideas in what I was using. And this is literally a one-for-one translation of those graphical blocks as code. And so what I like about this is if you, maybe if you're new to coding, just figuring out the logic and using the graphical interface is more comfortable, but then you may want to go and peek at the typed code because that's going to give you some skills when you start dealing with regular other languages. Also, sometimes it's really convenient to do things copying and pasting inside of the typed code. So if I have a block, let's find something likely here. How about if we were doing a whole bunch of different rings where we're going around this thing 5 times, rather than going in and making this if, else, 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 else statement, or else if graphically, which you can do by clicking plus sign, plus sign, plus sign, and then you'll be doing a bunch of copying and pasting of blocks and moving them around. You may actually find it easier to go into the JavaScript code and do something like that here. So I could copy this and paste it a bunch of times and then change some of these to else if, and then maybe get different color values for each time through. And then you can go back to your code. I've ruined it by not making all those else ifs, but normally you can then swap back over to your code and continue. So I find it useful to draw the connection between the graphical version and that text version. So let's see, I think that covers everything I wanted to show. It's making a couple of different DIY hand wash timers, of sort of 2 levels of polish to them, or skill and flash and style to them by having the graphics on the clue. It's very cool. You may not be surprised to find out that's the one my daughter prefers, and that's the one that's permanently in use in that restroom. And also a couple of different approaches that you can take as far as coding styles, and a couple of different pieces of hardware. And the nice thing is that this stuff is universal. You could use a lot of these skills on an Arduino, on a Teensy, with a microbit. Many of those will all work inside of this same environment. Some of those will also work inside of the CircuitPython environment. And that I think is a great way if you're new to building and making and microcontrollers, or if you're an educator, some of that might be interesting to you. And I think that it also is a sort of a fun way to do something that is actually useful and meaningful. There's nothing wrong with whimsy. Just ask me and my good friend Lars here. We like weird, fun, whimsical projects that have seemingly no point other than to make you smile. But this is one of those projects that has a real function. It's one of the projects that's in use many times a day in our house. And so I think that being able to respond to something like this pandemic quarantine that we're in and build a functional item in your house that involves some creative problem solving and some learning and some coding, some hands-on hardware is a lot of fun. And also, not that you want to lug your laptop into the bathroom, but you can build these projects in Make code without any hardware at all. So if you want to get started, you don't have any hardware around, you can just go to the makecode.adafruit.com and build projects right inside of that simulator. So there's sort of a zero barrier to entry other than having a computer, or I think even some tablets, maybe the iPad and Android tablets, maybe even iPhones and Android phones. You can use Make code pretty much as long as you have a browser that's compatible. So that is my my presentation. I want to thank everyone for coming out. If anyone has any other questions, I'll check the chats here. We have a couple more minutes before we end, but I love to end on time so that people can get on to their next thing. We can show the next scheduled item that's happening. I hope people are enjoying the virtual Maker Faire. Let's see. No questions that I can see. Daniel Martin says, "I do love being able to swap." Yeah, it's really excellent to be able to swap your code versions there. I think that's a terrific feature. Johnny Henry Caballero asks, "Can I program the Trinket M0 in this software?" Yes, you can. It's maker.makecode.com, and actually that was answered in the chat by the Adafruit account. Thank you. That may be PT, maybe Lamore, maybe someone else, but thank you. Yeah, the Trinket, the Gemma, some of the Metro boards, some of the Feather boards, even some the arcade hardware I didn't mention. lots and lots of hardware can be coded inside of MakeCode. So check it out. All right, I think that we'll wrap it up then. Thank you so much to everyone at Make Magazine. Thank you to Dale, thank you to Caleb, thank you to Mike Sinise, Katie. I'm sure there are other people I'm forgetting, and I apologize for that. Also, Mario the Maker Magician, who's been doing a great job hosting and entertaining with Maker Camp and now the Virtual Maker Faire. Thank you so much. We appreciate it. Thank you, Lisa, Maker Faire Long Island. Thank you for tuning in. I appreciate it. Also, Jim Hendrickson. Hey, Jim. Thank you, everyone, and enjoy the rest of your Virtual Maker Faire. I wish we were all together, but one day we will be again in a real physical Maker Faire. Thank you so much. Bye-bye.